Okay, hello everybody. Today we'll be discussing about um, the the effects of friction, which is an example of a type of forces. So first of all, let's see what is actually a frictional force. A frictional force is actually a force that opposes motion. Now, what do we mean by this is when the ball actually moves in this is being pushed towards the right, there is actually, so let's say this is force, pushing force. There is actually an opposing force acting on the ball itself in an opposite direction that is indicated in red. This would be what we call friction, where it actually opposes motion. So things that actually slow you down is an example of frictional force. Now, the second thing is this is an example of a contact force that if you have remember in our previous video, we talked about the different types of forces. Now, under contact force, you would see that the ball surface that is highlighted in yellow is actually in contact with the force of the floor. The surface of the floor. And in this case, friction is actually an example of a contact force. Now, what are some of the factors that can actually influence friction? Friction depends on two main things. Number one, we have the smoothness of the two surfaces that are in contact. The other one is actually the force pressing the two surfaces together. So what we meant by smoothness, so there's actually two main types of smoothness. There is actually very smooth and very rough. Now what is smooth? Smooth is like when you have a puddle of water on the floor and then you are able to slide it very easily, or when you play with the slide in the playground, you realize that when you sit down, right, you will actually be able to move down very quickly. Okay, so this is an example of smooth. Rough is like, for example, on the physical road, on the traffic light, where cars are moving, you would see that there is a lot of small little rocks protruding. So usually smooth is one very nice flat layer, whereas rough is very jagged. And of course, the more jagged it is, the more rough it is. So what will happen is when the floor is very rough, you couldn't really move that much. I mean, like you couldn't slide that easily. For example, let's say you try sliding on the road versus sliding on maybe a slide. Which one will feel more pain? It's actually the road. Why? It's because the road surface is very rough, and due to the generation of that friction, right, opposing your movement, your skin will actually be able to tear, okay, and then you will injure yourself as compared to the slide. So that's what we meant by smoothness. The other one is the force pressing against pressing the two surface together. So in a way, you could say that when you push something, okay, when you push a box or things like this, on the surface, which is located at this particular area here, there is a type of force opposing it, and of course, the greater the force here, it is harder to push. So it must be, so in that sense, that's what we meant. Okay, and then another area is actually gravity, but we will not touch so much of that in this particular area. Okay, so while we know that frictional force is dependent on the contact of the object with the floor, how do we actually how do we actually understand friction is through the surface area? Now, it's not just sufficient to say surface area, you have to say the surface area in contact, because only when in contact then there would be frictional force. If it's an exposed surface, like for example highlighted in purple, see these areas or this side of the cube, they do not undergo any form of frictional force because they are not in contact with the floor. Okay, so friction does not depend on the surface area in contact alone. So a rectangle block experiences the same amount of friction no matter which side it is placed. So what this means is is basically if you are whenever you are in contact with something, there will be friction. However, the surface area will influence how um, the surface area basically would not also directly influence the frictional force exposed onto it. So just take note of this. This is a common MCQ question that they can actually take notice of. So as long as there is some form of contact, there is frictional force. Okay. So how is friction a useful force? Friction is a useful force in that it helps us to walk without slipping. Okay. So in a sense, when we walk, our 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 feet generate some form of opposing friction, allowing us to actually move. Same thing, the tires are all of your this kind of tracks, right, helps to increase the roughness to allow us to actually move the bicycle. Okay, now, but the thing here for this picture is this particular area here, where there's actually a brake pad. In what this brake pad will be in contact with this particular surface of the tire, resulting it to actually slow down and to brake. Okay, and then of course frictions help us to grip things and also to help us to ride. Okay, so you have the pencil that actually does the friction the writing from the paper with the pencil itself, and then your fingers are also in contact with the pencil. So the fingers contact with the pencil is the gripping force, whereas when the pencil is writing on the paper, that's also an example of a frictional force. So then, is friction always useful? Okay, friction can also be a nuisance. Nuisance meaning it is like in a way, not, I wouldn't say that much harmful, but it has but it's something that you do not want it to be present. For example, you do not want someone to bother you and be a nuisance to you, to disturb you. So friction can also be a nuisance, and it produces as it produces unwanted heat in machines and cause wear and tear. Now, heat generally makes something hot. So for example, imagine some of you who are using the iPad, you feel that after prolonged usage, you will feel heat from the iPad or any form of devices. Generally, or you could say when you go cycling, okay, then your tires will actually undergo becomes thinner and thinner and thinner until it undergoes wear and tear. That is because of the heat generated due to friction. So friction can cause wear and tear, and when it causes wear and tear, you have to replace the parts. And when you replace the parts, it costs money. Sometimes it can even cause danger or safety measures. So that's why friction can also be a nuisance indirectly in this sense. So how are we then able to reduce such friction? You either use a lubricant or ball bearing. So a lubricant is basically a solution, a liquid solution to help to reduce the friction. So it make it slippery. So this is a lubricant. Okay. On the other hand, ball bearings are basically um, items like this. So it helps you to continuously spin. Why? Because within the ball bearing, okay, so let's say this is a particular nut, okay, there are multiple wheels in between it. So these wheels will help to reduce the friction by rotating. So imagine it acts like wheels, and then the whole thing will actually move in a circular manner. So these are the things that helps to reduce frictions further. Okay, so we have come to the end of discussing what is friction. In our next video, we will be discussing how do simple machine works and how do they actually contribute to forces. Okay, do pause the video, reflect what you have learned, think through what you have learned, and I'll see you all in the next one. Thank you.